Hello, everyone. I'm Sergey Vasilyev, co-founder and CEO of Empow Lighting. We have developed a new kind of LED technology that takes the form of a thin and flexible sheet that emits light. So now we apply this technology to retrofit outdated fluorescent fixtures in commercial buildings. This technology actually comes out of our lab here in Sacramento. We invented it and initially developed it with the help of funding from the US Department of Energy, and now the continued development is being funded by the California Energy Commission and a private investor. So it's on the core technology. And also we have gotten the CalCEF grant to actually develop this particular product, the retrofit I'll be talking about. So the problem we are addressing is our buildings consume a lot of energy and have generally inadequate lighting, so very outdated lighting, I would say. This lighting is dominated by linear fluorescent fixtures. So most people hate these fixtures because they produce very choppy spectrum, not nearly the quality of the daylight that we have all evolved and have adapted to. It requires periodic lamp replacements, and these lamps are a source of pollution because they contain mercury. And the worst of all is that this light that they generate costs the ratepayers, which are the building owners and in many cases tenants, almost $30 billion a year just to produce light. So the LEDs are of course a great alternative, everybody knows that, but unfortunately, the LED penetration into this market segment, into the linear fluorescent, into the linear light fixtures, is only 6%. And the main reasons are the constraints because of the high cost of the replacement fixtures, and also the lack of visual differentiation from the incumbent designs, especially in the case of retrofits. So like in this case, I mean, these lights are maybe LED, maybe fluorescence, but you don't know. Like in this back room, you can see like a typical office style fluorescent lights. And there are probably thousands of them in this particular building. So the way we solve this problem is that we use this thin sheet LED lighting panels, which we trademarked as Core Glow, and we simply insert this panel into the existing fluorescent lighting fixture as an overlay. So basically, the key value proposition is that you get the very low cost retrofits that instantly converts the outdated fluorescent lights into advanced LED technology without a lot of effort and without having to replace the entire fixture. So the instant benefits is that you get the bright, visually appealing indoor environment that stimulates the senses of the viewer. You also get the highly uniform, glare-free, and a completely environmentally benign light source. And you also get 70% energy savings compared to incumbent lighting. And because of the combination of this energy efficiency and the low cost, it only pays for itself in less than 1.5 years. Our customers will never have to replace a burned out lamp, and also will enjoy all of the benefits of advanced LED lighting, and which will add several lead points to the buildings. And another feature of our technology is that we are going to integrate the smart controls into this retrofit product. So the fixture will dynamically change the brightness and color in response to the user input, and also in response to the availability of daylight and to the many other factors like circadian cycle of people and distributed energy demand. So our technology compares nicely to the competition, which include the incumbent fluorescent fixtures, obviously, and also the replacement LED fixtures and the LED retrofits, which are typically the tubular LEDs that are installed in the same sockets as the original bulbs. And our technology has advantage in practically every category that matter to the users, and particularly in the cost and the performance and the ease of installation. It has no hazardous materials whatsoever. It's highly customizable, not only in the form factor, but also in the shape. We can make three-dimensional shapes. We can also import different patterns that can be customized to the need of each particular user. So you can have like different fixtures in a single room, and we can make them without having to do any retooling. So just using the same manufacturing technology that we were using. In order to keep these advantages, we have established significant IP barriers, including about 20 issued patents. So we're still a small team of scientists and engineers, but we have some world-class expertise in optics and illumination systems and a passion to make an impact. So the primary market, as you can figure out, is basically the replacement of the existing fluorescent fixtures. Typically, it's the troffers, so 2x2, 2x4, and 1x4 troffers that you typically see in office buildings. So there are about 6 million commercial buildings, and all of them, virtually all of them, have fluorescent lights of this kind. And there are more than 1 billion of them. And more than half of them are this specific troffers, like 2x2 and 2x4s. So this alone provides almost $20 billion total potential market opportunity for the next 10 to 15 years. And of course, these panels can be used everywhere. So, and other markets are also very attractive. For example, the architectural lighting or some high-end or especially lighting fixtures, also the backlights for illuminated signs and displays, and also the grow light market provides a very interesting and very significant market opportunity. So our path to market, we're about half approaching the midpoint of our in our path to market. So we have already developed and demonstrated the core technology. We have also developed the concept of the retrofit itself. We have conducted the market research and customer discovery and secured the IP. So what's remaining is addressing the technical risks and also developing the high-performance prototype that can be demonstrated in the full-sized, standard-size fluorescent fixtures, and including the third-party testing. We'll also need to obtain the certificates like UL and DLC, and also establish some pilot manufacturing and conduct field trials. Thank you very much for your attention. We'll be happy to answer your questions.
Thanks very much, Sergey. The pictures don't do it justice. I mean, this thing is so lightweight, and it's so simple. It's very clever. But I guess you're basically managing internal reflection in the acrylic panel.
That's right.
To spread the light out.
That's right.
And you're also being very modest in terms of mentioning customer interest. But you already have, as I understand it, considerable customer interest in this with some of the bigger manufacturers. Can you comment on that?
That's right. Yeah. So we're already selling like the components of this panel. So we're not selling the complete panels because we're still developing them. But yes, Gary is right that there's a considerable interest in the industry to this kind of panels, because almost everybody you talk to today in the lighting industry says that like thin and flexible sheets that emit light is the next big thing. And we're the company that is providing this technology. So nobody else has figured out how to make these panels inexpensively and which has the potential to make them on a grand scale. So in most cases, the experts in the lighting, they're thinking about like OLEDs, which stands for organic LEDs. They are available like in the form of panels, and today you can find like electronic displays, like LG makes them, like which are OLEDs, but they're still extremely expensive. So for a panel like in a 2x2 form factor, you're talking about like $1,000 per panel. In our case, it will cost 20. So.
Very good. People in the audience should be thinking up questions too, but let me turn to the panel first. Maria?
So I had the pleasure of seeing your prototype at Jackson in Oakland, and I just love the sound it makes. It really is, and it's beautiful. So it looks like it's functional. Can you explain where you are in the process? And also, since you mentioned the cost at a very reasonable $20 per panel, what is the cost to you? You're manufacturing in-house, is that right?
That's right. Yeah. So right now we're just manufacturing individual panels to the individual orders of our customers, and just making the components. So we're making these light guides to and send them to some pilot customers to demonstrate what this technology can do, and also providing the consulting services like pre-licensing consulting services, helping the customers to design their own lighting fixtures using our technology. So I'm not sure if I answered your question.
You said that the cost per panel is
Right.
Roughly $20. What is the cost to you, and how are you able to make it that low?
So it depends on the scale. So with like a high enough scale, we will have a very healthy margin. And again, the $20 will probably be like 2x2 panel, like 2x4 will probably cost a little bit more, maybe $30 or $40. And again, also the cost will depend on the features that will include. So depending on the CRI, which stands for the color rendering index, like the quality of light. So the high CRI panels will cost a bit more because the LED sources cost more. And also, if you want to customize it, it might also add to the price. So we're thinking about like the very broad price range, roughly from $20 to maybe $500 if you want like very large panels, like 3D shapes, and maybe with some features like high-end type of materials.
So where are you in that process? Because what I saw, the prototype was very functional. So where are you in it?
Yeah, so right now we're working on scaling up this technology to larger sizes, to like 2x2 and 2x4 standard sizes of the troughters. Also, we're working on enhancing the performance. So basically what we want to get out of this technology is that to at least match or even exceed the performance of like the high-end LED replacement fixtures, which are neither flexible nor transparent or customizable. So we want to come up with a technology which will not only cost less, but it will also perform at least as well, or maybe even better than the state-of-the-art systems.
Other questions?
Sure. I think what we're trying to figure out is also like what it really costs to make. Let's say if it's like $20, what's the profit margin? Is it like half of it, or?
It's slightly more than half.
Slightly more,
Yeah.
Okay. And like, do you have a manufacturing partner that you eventually want to let them do it, or do you always want to manufacture it yourself?
Yeah, it's a good question. So we're still learning what our options are, and when we're in the process of establishing the supplier chain. So we have already established the almost unlimited access to the acrylic materials that we need, like to the LEDs, and also to we're also using outside contractors, contract manufacturers for making the LED engines. So we're not making the engines or LED ourselves. So we're just doing the assembly, and we're also patterning these light guides, the sheets, to actually extract light and make them emit a uniform beam. And this is a part of our proprietary technology, and actually we make this patterned light guides here in Sacramento.
Okay. Just one question, sorry. How do these lights get here? Like, is there a partnership or customer who gets it here? Like, how does it get here?
Right. Yeah. So there are different ways how to do this, and one I would say maybe preferred way to do it initially is to contract the real lampers, the companies that are actually doing the retrofits. So they are very familiar with retrofitting the like fluorescent fixtures, like with these tubes and some other forms of retrofits, and So we have talked to quite a few of them, and seem to be very interested in trying this technology because they're sort of familiar with this and they know their customer base. So we're trying to actually target this kind of pathway to enter the market.
Over the question back here from Elaine.
Yeah, it's a very good question. Absolutely. So we can use any kinds of LEDs that are available on the markets, and there are RGB LEDs and white color LEDs which produce like different color temperatures. So basically, by selecting the light source, which we use in the LED engine, we can provide any color and even the ability to change the color dynamically.
So you showed the picture as a fixed flat surface. Could it be curved? Could it be mobile? Could it be flexible?
Yes, absolutely. Like you can see in this picture. So it's a part of our value proposition for other markets, not maybe necessarily for retrofits as well, because we can install it in the curved configuration, which will make it a distinct style and provide an additional differentiation from the incumbent designs. Exactly, yes, and there are many ways, and actually part of our IP is actually different shapes and different configurations, like 3D configurations of the lighting fixtures that can be made using this technology. That's right.
Maybe it's sort of like a weatherproofing layer, thinking more outdoor applications and things.
Yes, we're thinking about it. We're not there yet, but you're absolutely right. That's very interesting, avenue to pursue.
The LED strips are just in the metal edge.
Yeah.
So
Right.
it would seem, I don't know, it
I
would
just
seem
see-
to be fairly easy to seal up.
Yeah, one application I'm doing microgrids is very interesting, but also is for like a large customer, like things like that, or your desperate to be changed out. That's like one big huge customer.
Brian?
Two comments, I guess, or one question. In terms of market validation, have you sold any yet? Do you have any customers that can give you a testimonial saying how great this is?
We have tried our technology in some of the customers' fixtures, and we've got a very great response. So we have demonstrated that we can provide the same kind of functionality that they have. I'm talking about some big companies, when we replaced their light guides, which are thick and inflexible, with our thin, like almost paper-thin light guides, they saw that they're even more efficient, and they're like several times more material efficient. So yes.
Yeah, you might want to add a slide or something that just talked about that validation.
Yeah, gotcha. Thank you.
Also, it looks like a great product. If you come to an event like this, bring it. Let's see it so we can actually touch it and see what it looks like.
Thank you. Yeah, will do.
Yeah, just two quick questions. The 20 issued patents, do they all relate to core glow? Or
Yes,
okay.
yes. These are all related to the core glow. Yes.
Okay.
Well,
And
for-
then-
I had a follow-on question on that, Jack.
Oh, go ahead.
What is the basis of the technology? Is it the flexible piece of it, or is it the LED that goes into it?
It's a combination. So there are several innovations that are packed into this technology. So it's in the LED engine itself, the way it's made, also in the way it is coupled to this plastic sheet, and also the part of innovation is in the way we extract light, so that we can get very uniform emission, and we can also make these light guides out of just the conventional plastic sheets, without investing money into very expensive machinery like micro application and stuff like that. So we're using the so-called micro printing. So actually it's like an additive manufacturing. We're actually printing these light guides on the just raw materials that we buy from a vendor.
Just one other question. I'm wondering if you've approached lighting companies. Sometimes in the venture world they say, what stage are you? Are you a feature? Are you a product? Are you a company? Or are you a ticker symbol? Right? There's various stages, and it seems to me that you've created an interesting feature for someone else's product. And I'm wondering if the capital solution or the strategic partner for you might be one of the lighting companies that's looking for an improvement of their current offering or something else to sell to their existing customer base. Have you talked to any of the lighting companies?
Yes, we initiated such talks, and we are seeing a lot of traction on that.
And I have one more question: are there any technical limitations to the size? I mean, like you said, you are doing 2x4s, but to make it bigger, is it
right? Yeah,
technologically
potentially
harder?
there are some technical limitations within like the very core technology, but these limitations are basically maybe 2x3 meters in size. So it's not really a limitation, and we can even go beyond that. So we have also come up with a solution how to make these panels almost infinitely large. So and we can inject light into this plastic sheets at any point at the surface. So basically, as long as you can make this plastic sheets large enough, we can actually make these plastic sheets to emit light and become lighting panels. So we can basically cover like the entire walls or ceilings or maybe even windows. I didn't talk about this, but one of the features of our panels, we can make them transparent when they're not illuminated. So you can basically put them on the windows, and during the daytime when they're not illuminated, you will get the daylight and the visibility. During the night, they can be turned on, and basically you can get light from the same source you're accustomed to.
Mike Bell and then Tony.
Yeah, in your previous slide, you mentioned your current step is to address remaining technical risks. Can you elaborate on what those are?
Right. Yeah. So there are several technical risks that are related to different aspects of the technology. One example is that we need to make sure that the thermal management is good enough so that this light coupling of the LED engine to the this lighting sheets is reliable and stays the same for the entire lifespan of the panel, which we expect to be at least 20 to 30 years. And so there are also other things related to like the performance and the aging of the plastic materials like this acrylic. But we're more or less comfortable on that front because we are using pretty much the same, or at least trying to use the same materials that have proven to work in the lighting industries, like in these edge lit panels. I don't see any here, but that they're becoming more and more popular, or say the materials that are used in the LCD displays. It's very similar technology to that.
Okay, let's take one last question. Tony, all of our companies will be here tonight also past 7:30, and you can discuss with them individually. But we do need to keep moving on. Tony?
Real quick question. Can you make a designer light that's 425 to 450 and 600 to 700 so it would be able to be used in photosynthesis?
Absolutely, yes. So the materials that we're using for distributing light, they're transparent in a broad spectrum. Right. And so we can, of course, use any light sources that emit lights in the band, spectral bands that are useful for horticulture.
And will it work underwater?
Well, if we make it waterproof, then yes.
Good question. All right, thank you very much.
Thank you.